So we're gonna use turtles to reinforce the topics we already learned. So please go to Canvas, okay, and go to Files. So please go to Canvas, go to Files, and go to the folder labeled Turtles. There will be 2 files there. I did not write this code. That's not me like disowning all things. That's just me giving a proper attribution. Let's see, who did write it? Luther Tikhonevich. So he released it into the public domain, which means we can use this however we want. Okay, which means I get to use this in my class. So there's 2 files, world and turtle. Okay, and so these were essentially used. So turtles is a programming paradigm for doing some basic graphics, and they are exactly what they sound like, and they're basically the easiest way that I feel like we've come up with to do graphics, at least for beginners in computer science. So you want to do these. So you want to create a new project, and you want to drag these 2 files which you downloaded into that project. So I'll go ahead and download it with you, right? So I'll go ahead and download this onto my desktop, right? Because this is source code, and your programs are going to need to be able to read this source code. So I'm going to download both these files. One is called turtle, and one is world. The turtle code represents a turtle. This is the third type of thing, not a module, not a program. It's a class, it describes something that exists. So a turtle is an object, and a world is an object. So these little turtles are going to live on the turtle world. Okay? So I've got now my turtle and my so let's see. So on my desktop, I now have a turtle.java and a world.java. So I'm going to close this, and I'm going to go ahead and drag them into my code. So this can be as easy as opening up your projects, right? So create a new project to put them in. I'm just putting in the same thing. I'm going to create a folder.
You put them all in main?
No. You're not going to. So watch what I'm doing. Okay. So I'm going to create a package over here for me, or a project for you guys, but I'm creating a package over here. So package turtles. Okay. And what you're going to want to do is use that wonderful feature of basically modern operating systems, which is that I'm going to take this. So notice I take them, and I'm going to drag them and drop them into my project, into the src folder or into the package if you've got a package. Okay. Okay, and I'll move them into there and open them up, and they should be there, and they should be good to go. You might have an error. Let's see what my error is. So it says world missing package statement. So for instance, I put mine in a turtle package. So I'm going to go ahead and say it needs to be in. So I'm going to go ahead and fix this. Alt enter, set package name to turtles, and same over here, set package name to turtles, right? But your IDE should automatically be able to fix this. So I'm going to go around briefly to each of you to make sure that you've got it. Right, so did you download them?
Yeah, I did.
So where are they?
They're right there. I'm trying to figure out where to open them.
Don't open them. So they're right there, so they're in your downloads folder. Okay, so go to your downloads folder. Right? Downloads. Okay. Drag them, and if you've got a project.
It's right here, bro.
Yeah, drag them into here. Okay. So instead of dragging them into there, though, I'd like to move these guys. Yeah, let's move them into here, because your other code is already there. And just hit the refactor, and that will magically take care of it for you. Okay, so now you've got your turtles class, right, is on, and these things should be ready to go. Okay. Yep, that's perfectly fine. That's to be expected because you put it into H. Right? And so that's because that you put it in internals. So it says up here that you're missing a package statement. Right? Like I said, it will yell at you that you don't have a package statement. You also need world because see how it's saying world? You need to also do the same thing and put world right here. Okay? Okay, do you have a project to put them in? Right. Or you can use one that you already have. So let's go ahead and do new project. Next, turtles. Okay. So now if we go to projects right over here, we can put them into here. So you don't confuse your turtles and turtle. Turtles is just the program you're going to run in. You just drag them into here. Okay. And now you'll get some errors. It's going to say that you should get some errors. Yep, set. So right over here on both files. So you're going to want to do this world. Change package declaration to turtles. So it just adds package turtles up there. All right. And same thing with world. That just means it's telling Java which folder to find it. Right. Okay. So drag them into the folder. Did you have that? You need your IDE open for them. Yeah, Eclipse. Eclipse needs to be open. Right? It's not just a matter of also knowing what goes in. So, right, you need to create a new folder for them to go into. Sure. This is good. Okay. Because okay, I'll be right back. But you want to create a new project and put those source files into there. Okay. And I suppose you're doing. You've got turtle and world already in there, so I'm fine. So double click on turtle. Yeah. So actually, sorry, mine. Sorry. Oh, you copy pasted it. Maybe you missed something when you copy pasted it. I think that was a possibility. Okay, yeah. So download them. Yeah. I don't think you copy pasted the entire code. So you gotta download them and just drag them into your first assignment folder. No, download it. Okay. So now, yeah, exactly. And now that they see each other, no problems. Okay. So now you want to create a new file to play with your turtles in there. Okay. Yes. You gotta save. You gotta save the load. That's why. I'm not saving. That's all. Here we go. Okay. So turtle. Great. Copy them. And now create. And now in your project, if you don't already have like a class called turtles or something like that, you'll want to make your own. Which I'll show you. You're gonna call yours playpen. You can call mine playpen. And you want a main. All right. So now that we've got that set up, right? I've got a. I'm gonna create a class I call playpen, which is a playpen for my turtles to work in, which is just simply my main class. Okay. Public static void main. Okay. So the first thing we have to do with turtles is that we have to create a world for them to live in. Okay. So world W is equal to.
Make a new one now?
Yeah, in the same folder, right?
Which folder?
in the same place as you have your turtles. So, right, notice how over here I have playpen, turtle, world, right? So you probably, when you made a project, you probably already have a folder. Oh, sorry, I already have an empty class for them to start working with. Okay. Playpen. So I've got a new, so first thing I have to do is create a new world for the turtles. And this uses the big world file that was already created over here. Right? All 208 lines of it to make a new world. Right? No. You've already got it. It's this one over here, turtles. Right? You can mess in here. You can play around with it and be there. Right? What I'm saying is that if you wanted to make a new folder, a new class, you'd right click over there and make a new class. Okay? Right? So here. So first thing we need to do is make a world for the turtles to play in. So I'm gonna create a turtle. Gonna call mine Leonardo. You can call yours Bob. Bob is probably better because three letter.
What about Bentley?
We'll call mine Leo.
What about Bentley?
You can do that too. And he's a new turtle that we're gonna create, and you got to tell him what world he lives in. So I'm gonna tell him W. Right, just like you have to tell Scanner where they're reading from. You have to tell Turtle where he lives, right? So we created a world, and I created a turtle. And that's pretty much it. Turtles are fairly straightforward. If we run this class now, it creates a little turtle. See that? Little turtle, right? Now, what's interesting about turtles is just the amount of stuff you can do, is the simplicity of the commands, but also the amount of stuff you can do with turtles, okay? Turtles don't seem like they're too interesting, but the way this works is imagine this is a little turtle and he's got a pen or a marker in his little turtle mouth, okay? And then as he moves, he drags this marker across essentially the world with him, right? Making marks wherever he goes. So for instance, if I tell Leo to go forward some amount, like if I tell him to go forward 100, and I run this, he drags his black marker forward. Right? Right, because okay, that makes sense? I can also tell him to change color. So I can tell Leo to set his color, and then I can give it a color over here. And notice that it starts popping up with suggestions. Color dot, I'll go with red. Right? Color is a nice class that will import itself automatically for you. Hopefully, java.awt.star. If it doesn't work like that for you, but now I can set his color to red, and that changes him to being red and having a red marker, and I'll move him forward another 100, right? So notice he moved forward 100, and then he changed himself red and moved forward 100, right? Nothing too crazy there, right? Now. Obviously, he doesn't do too much. Now, he doesn't do... And to close this program, you just have to hit the X button. Remember to hit the X button. So Leonardo's doing a pretty good job so far, I think. He can change colors and he can move when we tell him to. Now, mind you, moving forward doesn't really do much. We also need him to be able to turn directions as well. Okay? Leo dot turn right. Right, so I can make him turn right. And this is the only bit of trigonometry or whatever, or geometry you're going to need to know, which is how many degrees are in the circle, right? So when I say turn right 40, when I say turn right 90 degrees, he was going to the right, and now he's going to start going down, right? This will angle him, right? So now notice that he's turned face down, right?
Yeah.
And now if I tell him to move forward a bit more, Leo dot forward
It's not reading mine.
100.
It's not reading mine. Getting out. Yeah, I'm getting out.
The D is nothing. That's something that gets popped up as a helper.
Or the color.
The color is fine. So D.
The color don't work.
The color has to be. So what's his light bulb say? Import the color. The D is just a helper that points up, that pops up in IntelliJ. So yeah, I never actually typed D. It's a helper that helps out. Notice how it's a different font.
Yeah, it says it's not working.
So,
It says the color isn't working. Cannot find color. Does it all need to be capitalized?
Well, let's take a look at what colors are. It has to be all. Yep. There you go. So Steve dot set color. Right, gotta read what I have up there, which says color dot mode. And then went ahead and imported it for you. Okay, so now it should work perfectly fine. Okay. Set color, not get color. Set color if you want to change the color. Get color if you want to know what color it is. Okay. Okay. So we can make Steve or Bentley or Leo in my case, or whatever you decide to call your turtle, go in a square fairly straightforward by making him, by repeating this command a bunch of times, right? Turn right and go forward, turn right and go forward another 90, right? We had him go forward, and then we had him turn right. Then we had him go forward, and then we had him turn right again. And if we do that four times, right, go forward, turn, this is 3 times over here, I believe, right? Go forward, go forward, go forward, right, and turn right again. And now if we tell him to go forward and turn right, he'll be back where he started with the red stuff when he turned to red, right? Right? Makes sense?
Yeah, that makes fine.
Okay. So once we turned him to red, we told him to move forward 100, then had him turn right 90 degrees, and we just copy pasted that 4 times. But remember what I said about copy pasting. That's a lot of times there's really no need for it. Instead, we can use a for loop to repeat this action 4 times, right? So for int I is equal to 0, I is less than, well, we want this to be repeated 4 times, so we'll put 4 there. And so we'll just put this in, so we'll just put leo.forward and leo.turnRight into a loop that executes 4 times, right? And that makes our code a lot more condensed. 2, 3, 4, right? So we can draw a square pretty easily. Right? And actually, it seems like a pretty cool thing to do, just be able to draw a square, right? So why don't we add that in as a new command, and what we can do? So public static void draw square. We can have multiple turtles going on in this, as also we'll see in a bit. So I'm just going to call this turtle T. This will tell this turtle, because we want to be able to tell this particular turtle, a specific turtle, to draw something. Right? And what we'll do is that we'll take this stuff over here and repeat it. So for int I is equal to 0, I is less than 4, I plus plus, I is, so then we want to tell this turtle to move forward 100, and then this turtle to turn right 100, and he'll just do this 4 times. And that way he'll not only create a square, but he'll be facing exactly the same way he did that.
Wait, let me see that.
And so now what I can do is rather than using this block of code over here, I can tell draw square Leo. I can tell, or whatever your turtle is, I can tell him to draw a square. So I run this. Oh, that didn't work out. What was my issue? My square doesn't look very square-like. So what's wrong with my code here?
Degrees 100.
I turned him too far, right? Turn him 90 degrees instead. Okay, that's pretty cool.
Wait, I'm fine. I messed up.
All right. So what's great about Turtle and Turtle Questions is that they're very good later on. They make very good test and quiz questions because I can make you take out a piece of paper and draw things, and they're very. And I don't really need too much to tell you to do that. So they're also good at basically being able to envision things. Remember, it's being able to see what happens with this code. Now, what I like about this particular class is that there's a number of interesting things you can do with this. Like, for instance, he's dealing with the turtles are just dragging along this pen, but they can also do some interesting things. Let's go ahead and I'm going to go over here to Wikipedia. I like this picture. Actually, I like this picture, Red Fuji. Really like this picture, known as Fine Wind, Clear Morning. More details over here. This is a bit big, so I'm going to get a small version of it. Okay. Right, so I did that by Googling Red Fuji on Wikipedia, and then I clicked more details on the picture, and then I'm clicking the 320 by 214. And I'm just going to grab this URL. Okay, and now in Playpen I can do this. Leo.drop. And then I can just drop that URL in. This is pretty fun. And he just dropped the picture in. Now it's facing this way because, of course, he's facing up, so I guess that makes sense. So maybe how do I need to turn it in to orient the picture in the right direction?
90 degrees left.
Turn him 90 degrees to the left. So let's go ahead and do that. Leo.turn left 90. Boom. Right? So I can drop a picture in just like that into that. So what about more complicated shapes though? Right? So I can drop pictures into here. That's pretty cool. What about more complicated pictures? Well, let's do this one. Public static void draw star, and this will take in a turtle just as well. So we're going to tell a specific turtle to do this thing. Okay. Now for int I is equal to 0. Remember, this loop just tells the turtle to repeat this particular task a certain number of times. I'm going to tell him to repeat this 50 times. Okay? Okay. Now,
yeah, I did an error on that one.
because you're not, because you weren't following my directions. You weren't naming the method the same thing I named it, and so, right, you need to give the method a name, right, which was draw square. You got to give a method a name in order to work. And then it needs to be, and then it takes in a turtle, right? Just like it takes in an integer. So then you redeclared it as an m, so it wasn't going to work. Okay. So you, again, follow what I have on screen. So t dot. So here, I'm going to tell it to go t dot forward 100 again. But this time, the angle I'm going to tell it to go forward is 144, which seems pretty random. T dot degree. So I want everybody to copy this one down, right? Do this, take in a turtle, tell that turtle that you take in to go forward 100 degrees, and then tell it to turn left 144 degrees. So, sorry, tell it to go forward a distance of 100, then to turn left 144 degrees. Okay, so I'm going to comment out, and the reason I like commenting, I'm doing these as methods is so that I can essentially save all these animations we're doing, because now it's where we're going to start getting some interesting stuff. Okay, so now if we run this, well, of course it's not going to do anything because I told it not to do anything, right? I just told it to create a world. So now I got to tell it to draw star, and I'm going to pass it Leo. I'm going to tell Leo to draw the star, right? I'm going to tell Leo to draw the star because I can also create a turtle Alice, right? Right, like I said, you can have two turtles here. New turtle.
I need to feed it code first.
I'll get back up to it. Right? So we can have a draw star, which takes in a turtle, and I'm specifying which turtle it's going to be drawing. And again, I'll make Leo dot set color. I'll make him color dot red. Okay, to differentiate him from Alice. So we run this now. That's not mildly ominous at all. Sorry. Alice dot set color. Let's change her to green. Color dot green. And let's see if they are able to tell differences apart. So for this one, again, for the code, let's make it less ominous and make it turn right 144 degrees. So here Leo's going forward and he's drawing a 5-pointed star. Now I'd like you to take a moment and experiment for a bit, because 144 gives me the star, but I'd like you to do some interesting things, like what if I try experimenting a bit and showing me what you get. What happens if I throw I in here, or I times 20? What happens if I change the degrees, like if I do I minus 144 minus I, or I try something else. So go ahead and experiment a bit. Modify the draw star, and and I'll come around and see what you've got, and just play around with it and see that making slight changes actually changes the animation a whole lot. Should probably work on the turtle stuff. It's valuable stuff. So is it working for you? So, okay. Code stack void. Why is it not? Acknowledged. Oh. So, part of the issue is control A, control. And A, and I. There's your indentation. 3 wrappings indents. There. You had 2 wrappings. There we go. You should be able to run it, right? You had to cross the code basis. Awesome. Okay. And now you should be able to run this just fine now.
So Where's the star again?
So if I'll try doing the star, to draw a star. Went off the map, but that's okay. Oh, coming back around.
Yeah.
Drawing a really big angled thing.
So the blue one goes back and forth and fuses with the black one.
Huh? Well, what did you do? That depends on what you did.
Yeah, I did the
180 means you turn the opposite way,
Yeah.
right?
Mm.
So now try turning it a slightly different 120. See what happens.
It's still running 8 knots.
Yeah. Well, yeah. So right there. Turtle run. 120 gives you a triangle because remember 120 plus 120 plus 120 is 360, which is the amount of degrees in the circle. So now try giving it a bit of a perturbation, like maybe 121. Right, because did you do the draw star? Yeah. Did you call draw star? Yeah.
Oh yeah, I don't think I called draw star either.
I think you're calling draw star.
Oh yeah, I say draw star, but did I say? Yeah, I do. I did draw.
Mm-hmm. All right. So we can make minor. What's cool is that minor variations. Let's say like instead I decide to do 142 degrees, right? They're gonna start doing little things that affect this. So here we go.
My blue turtle can't stop. It's doing the same thing that yours is doing.
Well, that's okay, because we did tell it to do it 50. Tell it to do 50 things.
Yeah, I know.
Right, and now it's kind of just drawing this flower-y shape, right? Just by doing a minor variation of commands, right?
Let's change mine to 80 and see what that.
Now, what's interesting here is that we can also start using the loop as a factor. So 100 plus I. So now we tell it to move 100 plus I times 5 distance. Okay. And this time we're still going to go the same amount of angles. So now as it moves out, we're telling it to move a bit further each time. And so the star just gets bigger and bigger. It's actually kind of spiraling out like that. Isn't that cool?
Yeah, mine looks like it's kind of making a star, isn't it? I mean, that's what it kind of looks like it's going.
So all I changed here was the distance, right? I said, so how did this happen? But how did this end up happening? Well, this was the starting location. I told it to move 100 this way, then 105, then 110, then 115, then 120, and so on and so forth. So each leg of the trip, each leg around the star, it got bigger and bigger and bigger. Right? So we can also tell it to draw like any arbitrary shape, right? We want to make it, let's go ahead and see this one. So public static void draw shape, right? Or let's say actually call it a polygon. Turtle. So we want turtle T to draw a polygon. We want it to have this many sides, and we want it to be this large. Okay? Makes sense? We want it to be so we want to draw a polygon with n sides and with the sides, number of sides, and be of a certain size. So for instance, I passed in 3, I want it to be a triangle. If I wanted to pass in 4, I want it to be a square. 5, it's a pentagon. Now, to draw polygons that sounds hard, but if you think about it, it's actually not too bad, right? Polygon Right? Those type of polygons, just general polygons, are a bit annoying. But if we instead go for like a regular polygon, which is, remember, a polygon with the same number of sides, which has the same distance on each number of sides, then it becomes a lot more manageable. Right? So we have our turtle go turn 120 degrees this way. Sorry, it'd be 120 degrees this way, then 120 this way, and then 120 this way. Right? Then we could draw a triangle. Notice that adds up to 360 degrees. Right? Notice the inner angles. The turtle has to turn 120 degrees. We could also do it 60, which is the reciprocal, but For a turtle to draw a square, we turn 90 degrees each way, which is 4 90s equals 360. For a turtle to draw a pentagon, we turn 5 times, right? Notice how the turtle to draw this pentagon would go here, then here, would turn, then go, turn, then go, turn, then go, turn, then go, and turn, then go. 5 total turns and goes. To draw a hexagon, which has 6 sides, it would turn 6 times, right? Everybody kind of understand that if it's an n-gon, right, you're going to turn 6 sides. If it has 6 sides, the turtle's going to make 6 turns, right, and draw 6 sides. So really the only question is how far should it turn? What should the what should the double angle that it turns each step of the way be? And, well, there's 360 degrees in a circle, right? So, and we want to draw that many sides. So it should be 360 divided by sides. Let's do 360.0 so that... And then what we'll do is that we'll tell it 4 int I is equal to 0. How many times do I want it to turn? Well, the number of times there are sides. And then I want the turtle, turtle dot forward, or I called it t. So t dot forward, I tell t to go forward however big we're making this thing. And then t dot turn left. Let's go turn left. Angle number of degrees. And now what I'll do is I'll tell Alice to do that before we have Leo draw a star. So draw a polygon. Alice, I want you to draw a 12-sided polygon, and its size is 200. So let's see what Alice does for us. She goes off the side of the screen, and she comes back, right? So about 200 per side was maybe a bit too big. So maybe we go down, maybe we tell her to do something a bit less ambitious. Size 50.
Could you bring up the method again?
Oops, sorry. So yeah. So you can have 2 turtles working in conjunction to draw things. Here's the draw polygon method. I tell there's 360 degrees in a circle, so in order to make a full rotation, I tell the turtle needs to turn that many amount of degrees. How many turns does it need to make? It's going to make sides number of turns, so that gives us the number of angles, and so we tell it to move forward that amount and turn that amount. So there's lots of interesting things you can do with these turtles. What other things can we do with turtles? Let's go ahead and look at the turtle class to see all the things that we can do with a turtle. Right, this is something that somebody wrote. Public, static, final, all this stuff we don't really need to worry about too much. Colors that are already ingrained to it. But there's methods on now telling it can go forward and backwards, to turn right, to turn left. Pen up and pen down, right? Pen up means it will pull up its pen and put the pen down. That means it will put Parker down. And then this is all the stuff that it used for drawing. Drop, which is what we use to drop a picture. Shell size. I guess how big the turtle is. Get the heading, which turtle, the way the turtle's facing. You can also tell the turtle to go to a specific location, right? If it's coordinate plane with 0, 0 being the center of it. So we can tell the turtle to do something along along the lines of this. Public static void turtle t, right? We can tell the turtle to do this. So let's tell it to do it 100 times. Okay, double angle is equal to 360 divided by 100. What we can do is we can tell the turtle to, let's see, go forward, t dot forward, go forward 50, t dot turn right 15, t dot turn left 25, t dot pen up, t dot pen up, t dot go to back to the origin point 0, 0 and put his pen down. And t dot turn right angle. And let's see what kind of mess I managed to draw. The same one as before because I didn't tell it to do anything else. So let's go ahead and tell Leo to, let's do, what was it? Weird. And I'll tell Leo to do that. So maybe I need a bit further. I need maybe, 100, right. And then I need to, forgot to actually do some movements here. Turn right 15 degrees and move forward 15, turn left and move forward 50. Now let's see what this draws. Right, so what is he doing? He moves forward 15. So he moves forward 100. He turns 15 to the right, moves 15 forward. Then he moves 25 to the left and moves forward 50 more. And then he jumps back to the center. Okay. And then proceeds to and then he turns a bit more and proceeds to do the same thing again. So this allows us to draw an interesting shape, which honestly isn't too interesting, but what we can do is we can also alter the color as he's going, right? T dot, so at the beginning of the loop, what we can do is that we can go like T dot, what's interesting, right, you've got this color here, but we can define new colors with 3 values, which I think I'll show this off here, and then we'll do it in a in a more interesting, sorry, in a better format.
Is there triple dot speed? If there's an
I'm gonna check if there's a speed. World might be under world. I don't know if there's a speed here. New color 100. Let's go ahead and see. There's 100. So R times 2. Sorry, no. I times 2. I and 0. R 0 and I over here. So now this will be interesting because now the turtle's color will slowly change as it animates. But will take a while, unfortunately, because there's a lot of commands for it to process. So while that's going, I'll go ahead and talk about color for a minute. Right. So when we create, there's all sorts of colors that you can create, and colors are defined by having 3 attributes. Okay. Does anybody know what the three colors are? RGB. Red, green, and blue. So we define colors as having an R, a G, and a B value, with 0 being essentially ending up being towards the black end of the spectrum, and 255 being towards the white end of the spectrum. So you give it a value between 0 and 255. All zeros means black. All 255s means white. So what I've told our turtle to do, and he's becoming browner as we go, is to essentially let I be right. So we're going to use I. Our red value is going to have an amount of red equal to I times 2. So at the end it will be 200, and then amount of blue equal to I. Oh, he's repeating it because, of course, because I don't want to necessarily do this 100 times. I did told to turn an angle. Interesting. Well, regardless, let's go ahead and take a look at another basic thing. Let's go ahead and do public static void draw, and I think this will be the last one. Draw square spiral. So here I want to create a spiral. The most basic spiral, a square spiral. Now to do this, right, I'm using a square here because squares are fairly easy, right? You just turn 90 degrees, right? Drawing squares as we've learned, involves essentially telling it to however long we want this to continue. So let's say I want this to have 20 sides. We tell the turtle to go forward, right, a certain amount, t.forward. Let's tell him to go forward 100. And then we tell him to turn 90 degrees.
Okay, I need time to...
Okay?
I need time to write that.
This one?
Yeah.
Okay. So, right, this is the same as the code as I have for the turtle to draw square, except for one difference, right? I'm telling it to do 20 times. Now, to make it be a spiral, though, right, what I had for a square, we have the turtle go basically the same amount in every direction. To make it be a spiral, though, we start out small, and then we get a bit bigger, and then we get a bit bigger, and then we get a bit bigger, and we get a bit bigger, and so on and so forth. Right? By telling the turtle to draw each side more and more, we can draw a bigger and bigger spiral. That makes sense to everybody? So what needs to change here is not the angle. Oh, sorry. It's turn right. So not the angle, but the forward. So that's turn right, not forward. The second thing should be a turn right. It shouldn't be 2 forwards in a row. So if we were to call this draw star, not draw star, draw square spiral Leo. Right now, he'll just draw a regular plain old square.
Yeah, it's having trouble with my integer now.
Did you do 4 in I is less than? Did you get this code down exactly?
Oh, right, it made int equal to 0 instead of int equal to I. Wait, it's still not working. Int I equal to 0.
Okay.
Sorry. Sorry.
Okay. So now, what we can do is that we can make every iteration of this be slightly longer. Times 10 times. So now if we change it to 10 times I, every step of the way, the turtle expands a bit.
Yeah, let me see. Thank you.
So we can change this from maybe we change this to maybe 100 to, let's say, 50, and change this to 10 times I. And now we've got a bit of a tighter spiral going out from the center. Right? But why don't we get it to try to change color as we're doing it? So T dot set color. Okay? And now what are we going to do? Let's go ahead and say new color over here, and we need a red value, a green value, and a blue value. So let's go ahead and say 5 times I times 5 for their red. Let's go with 0 green, and we'll do 255 minus I for our blue value. So we're going to start out blue, and we're going to get more and more red as we go, and less blue. So here's our blue turtle going, and our turtle's slowly getting less and less blue, and it should get more and more purplish.
Matthew? So you do that after the...
Mm-hmm. And if we want to alter this a bit, we can maybe add a bit of green in here too. See what happens if we add in a bit of green and add a bit of green as we're going. So the maximum amount of red this is going to be is I times 50, which is going to be 50 times 5, which is 250. Let's go ahead and see how this changes this out. So now we've got a bit more of a cyan shape, but now we get a bit more.
I'm trying to.
All right, all I did was I didn't change much. So we can change the color as we go along, which is pretty good, which is pretty cool.
I'm trying to see that. I can't really see the color.
There. So, well, what it doesn't rather matter. What it is to experiment. So you have the you have I times 5, then you have G plus I, and then you have 255 minus I. We have 100 plus I, not G minus plus I. So you've got all these values, and the turtle changes its color as we go. And now what's interesting is that we can do something like int step to tell how big the turtle, how much we can tell the turtle how much to step. So instead we're going to do step times I. All right. Now we can tell Leo to go maybe a step of 10 and draw spiral Alice and let her step maybe be something small like 2. And that will take a bit of time to animate because, unfortunately, with turtles, they are slow, right? But that's, yes. What? Okay. Because you need to. Are you? So because you have to move forward a bit more each time. Instead,
Yeah, it's like, I can't really make that.
times 10 times I, right? And now it will move forward a bit, right? So the first time it moved 10, it will move 0. Then it's going to move 10, then 20, then 30, then 40, then 50. So right, 0, 10, 20, 30, 40, 50, right? So on and so forth. Okay. Right? So.
That's an error here.
Right, because you're missing a space. New color. Okay. New color in blue. Set color. Why does it say semicolon? Not.
That moved it down there.
T dot set color. Because you're putting in red, green, and blue right now. You just put in the numbers. Again, that's my IDE just trying to tell me what I'm putting in. Right? And now.
Yeah, it's saying I have a lot of errors. It's not. Oh wait, I don't know. Did I?
Alright.
No, I called it. It's just saying it's just not moving. It just wasn't. It said the
No, you don't have error. But job return 1. Let's see. Did you save it? Here, excuse me. You. Again, so run the turtle. And color expand, you've got too much blue. 255 plus I.
Right. Sorry.
Right. The value can't, for colors, the value can't exceed 255. So I had 255 minus I. All right. So anyway, I think that's all I have for you guys this evening.
Oh, okay.
So, on Thursday, I think I'll have some exercises to do with turtles in class, and then, yeah, that's about it. I think on Thursday, that's essentially it. We'll just have some exercises for turtles in class.
Okay.
Sorry. Yes, we'll use this stuff to do some exercise to make sure we're understanding our loops properly. Okay.
So we can exit out this now?
Yep.
It said it will